So what we're going to try to do is to calculate the wavelength of light when you transition from an upper energy level to a lower energy level. So let's just say this is what my example will be. When an electron transitions or drops to a lower level, energy is given off as a photon. The electron is losing energy, so its change in energy would be negative, but the energy of the photon that's given off will be a positive number. Okay, and we're going to use these equations in this order. I have this to match the lab equations. Okay, and so this is the energy of the electron at each energy level n. We're going to use these constants. This E is the energy of the photon, and notice that for the photon, the upper is really the initial, where the electron starts. And so it seems kind of backwards that for the photon we usually do final minus initial, and it's because we're talking about the photon and not the electron, but this is the order that this goes in. This will give you a positive value for the energy of the photon. This next part is for the photon as well. This equation is for light, and we will have our energy of our photon from this part, and we'll be solving for frequency here. And then once we know frequency and we know the speed of light, again a constant, we can solve for wavelength. And we'll be able to see where that falls on the spectrum. So let's look at this example, and we're going to do these calculations in the order that I showed you on the last one. We're going to start by finding the energy of an electron at a certain energy level, and we're going to do 3 because we're going from 3 to 1, and so our equation is this. N, of course, is 3, and this is Rydberg's constant. These are negative values. That's because they're more stable than when the electron is totally away from the atom. And then we'll also do the same for n equals 1. Okay, and then we have our next part where we're going to see the energy of the photon released. So the energy of the photon is equal to the energy of an electron in the upper minus the energy of an electron in the lower. Again, this seems kind of backwards because it's initial minus final, but that's because we're talking about the energy of the photon and not the energy of electron. And so it's reversed. And we're going to plug in our numbers from up here, which is on the first page of your lab here. Okay, and notice this comes out to be a positive number. The energy of the photon is always a positive number. It cannot be negative. Okay, next step. plugging in Planck's constant. And solving for frequency. Oops, that's not a very good one. We can plug in our constant for the speed of light. And last thing we might want to do is to change this to nanometers. It's kind of common to do that, and on your lab assignment they have you do that. So and that's our answer. This is the wavelength of light. Okay, I want to review something about these signs real quick. Notice that the energy of an electron is a negative number. The energy of a photon is always a positive number. Frequency is a positive number. And wavelength is a positive number.